Hello, everyone, and thank you for joining us. Welcome to this presentation, which is part of an ongoing Goose webinar series exploring aspects of global sustained ocean observing. My name is Albert Fisher. I'm the director of the Global Ocean Observing System Office, which is headquartered here at the Intergovernmental Oceanographic Commission of UNESCO in Paris. And for the next hour, we'll start with about a 30-minute presentation on the Global High Frequency Radar Network, which will be jointly presented by Hugh Roarty, Lisa Hazard, and Julien Madel. Hugh and Lisa are amongst the co-chairs of the Global HF Radar Network, and Julien is the chair of the Eurogoose task team on HF radars. So the Global HF Radar Network got its start in 2012 as a geotask, the Group on Earth Observations, and it was recognized through JCOM as Goose Network in 2017. Hugh, Lisa, and Julien have all helped to develop this network into the global collaboration that we're about to hear about today. After the presentation, we'll conduct a question and answer session using the question window, which you'll find in your interface. And if you ask a question, which you can do during the presentation as well, please ask it by clicking the Send to All button so that all of the participants can see the list of questions. I'll be moderating and asking the questions verbally, and the question window is already open, so if you want to go ahead and ask questions during the presentation, please do so. We're recording this session, and the link to the recording will be posted both on the Goose webpage as well as on our YouTube channel, where you can find all of the old webinars. So Hugh, I think you're starting the presentation, so we'll go over to you for the presentation. Thanks.
Okay, great. Albert, thank you. So thank you for providing us the opportunity to share with you an overview of the Global HF Radar Network. And thank you to my co-authors, Lisa Hazard and Julien Madel. So the Goose strategic mapping was developed to visualize the linkages between the requirements, observations, and products associated with ocean observing. There are 31 essential ocean variables, surface currents being one of them. Today we'd like to share with you an overview of one of the observing tools of Goose, HF Radar, and how the community has organized to disseminate surface current measurements globally and develop new understandings of the ocean through these high-resolution, long-time series measurements. So just a quick overview of the technology. We'd like to show a 5-minute video that was developed through USIUs that we feel gives a good introduction to the technology and one of the applications of the measurements. So let me play that here. Oh my God. Well, that doesn't seem to work. All right, so since the video is not going to work, let me take you through some of the overview of the technology. HF Radar is a remote sensing tool that transmits radio signals that couple to the ocean's surface. The range of the radars varies between 30 to 200 kilometers from the coast. So the systems that operate that have ranges of 200 kilometers can obtain a radial measurement of currents, as shown here, typically every 6 kilometers. And then the higher frequency systems that operate at 25 megahertz can obtain measurements only about 30 kilometers from the coast, but you can obtain a measurement every 1 kilometer. And then typically you get a radial map of ocean currents once an hour, and then the radial measurements from several stations are then combined to then provide a map of ocean currents, as shown here off the coast of Spain. There's two main sensors that are used to measure the ocean currents. One is a direction finding system. That's typically one or two antennas that are located along the coast. And the other type is a phased array system where it's maybe 8 to 12 elements located in a linear array that are also used to measure ocean currents. Okay, so as Albert mentioned before, the Global HF Radar Network was established in March of 2012. We held meetings once a year in Norway in 2013, Greece in 2015, in order to establish the network and to meet with the community to establish the goals. So the goals for the radar network were outlined here. We wanted to increase the number of coastal radars operating globally, and ensure that the data is available in a single standardized format for community use, work on assimilating data into ocean and ecosystem models, and develop emerging uses of HF radar measurements. So this figure here shows the growth of HF radar stations within the US. So the timeline goes from 2004 to 2018. And you can see here is a rapid growth and now a steady maintenance of approximately 150 radars within the US. A similar picture is shown here in Europe. Again, starting around 2004, and increasing now to present day of 2018, where just over 60 radars operating within Europe. The green lines indicating radar stations that are still operating, and then red lines indicating stations that were operated for a particular time period, and that data is available historically. And then a picture here within Asia, a map of the radar stations around Korea, starting a little bit earlier in 1999. Approximately 45 stations currently operating in Korea. Thailand, they had a two-phased approach where the Gulf of Thailand was covered by systems. Here's a picture of one of the stations that was installed in Thailand. And then another picture of HF radars around the island of Taiwan. The island of Taiwan is completely covered with HF radar. And something that's just been happening recently is we're finalizing a memorandum of collaboration between the global network and the Taiwan Ocean Research Institute for data sharing and participation within the global network. So if anyone is curious to be able to visualize the surface currents of the global network, it's available through this URL here. And just an overview, there's approximately 350 individual HF radar stations operating within 35 countries globally. And of those 35, 9 of them, and hopefully soon to be 10, are sharing their surface current data through this URL here, globalhfradar.org. So now I'm going to turn the presentation over to Lisa Hazard, who's going to talk more about the some of the applications of HF radar measurements, as well as how to access and visualize the data.
Thanks, Hugh. Okay, let's see. Okay, so I'm going to just start with some of the applications that are kind of worldwide. These are some of the efforts that are happening in the U.S. For the use of HF radar-derived surface currents. So many of the applications can center around maritime operations, oil spill response, water quality, ecosystem management and modeling, and recreation and research. Some of the tools that within the US, there are feeds or access to folks who are doing modeling or emergency response management in oil spill response. The data is integrated into a short-term prediction system for feeds into the search and rescue optimal planning system within the Coast Guard. The Advanced Weather Interactive Processing Service is getting the data for maritime operations, as well as we have a physical oceanographic real-time system, ports, where the data is displayed. Starting to get integration into models for ocean forecasting, regional models, and more broad models. And then folks use it, for daily check through search and rescue within classrooms, fishing and boatings, and we have displays in aquariums. So some of the areas of growth within the mapping and HF radar tools, the systems, Hugh went over the kind of basic use or operation of the systems. The antennas can have calibrations, and we're starting to use drones and autonomous systems to do calibrations of the antennas. A lot of the efforts going into kind of getting the data globally and interacting with one another is also getting a Quartad manual for the quality control of the data itself. There are many folks who are starting to look at HF radar output and have a Waves product from it. And so there's some operational testing going on in several countries. There's not really coordinated efforts at this point, but there is a lot of work going into using the technology for wave measurements, as well as Medio tsunami warnings. So the Waves is a little bit further along from a kind of integrated and operational viewpoint, and the Medio tsunami warning is just getting into, just starting to be looked at. And of course, again, kind of going through getting the data integrated into products is a very big area of growth right now for the community. So the way that we do that is basically through data sharing and using common data formats. So this community has been very fortunate in kind of the technology sort of come up to speed and coming into an operational usage with a lot of data standards already in place. And so the common distribution for the near real-time total vectors is the NetCDAP format, using standard metadata naming conventions, using the climate forecast interoperability metadata naming conventions, and kind of using the standard metadata dataset discovery. Many of the endpoints for getting the data operationally and into other systems is using a data standard distribution service called the Threads data server. So having these conventions already in place as the technology has been developed has really been able to sort of launch the technology and the data distribution to a very high level at early stages. And the global network and the global community kind of coming together to use these data standards has really enabled such the broad collaboration. So currently, there are, as Hugh brought up, there are many countries who have these networks set up around their areas. There are currently 9 different countries who are actually sharing the total vector currents, and that list is here. And the European Marine Observation Data Network, EMONNet, has put together kind of a nice, let's see if I can bring that up, threads catalog of all of the endpoints. So while they're not the host of all of these, they link to the endpoints for all of the threads services for those who are sharing data globally. So this is a really good resource if you're looking for the total vector files in those countries who are sharing data. And then we also have a visualization tool for bringing up all of the total vector currents for those countries who are sharing data. So. Also, there are many sort of groups who organize and help foster the global collaboration. One of them is the Radio Wave Operators Working Group called ROG. ROG just recently put together bring this over again, a GitHub repository for languages and code that can help you manipulate the information and bring it up in your own toolboxes. So this is a really nice resource to come to for any kind of like coding. I know this HFR Progs is a very big utilized MATLAB toolbox for integrating radial files to the total vector files. So these are all available for use. Let's see. One of the things that this network did to organize and to ensure that we were a global network was the assessment review. And basically, during our assessment, we determined that this is now global measurement. It is sustained, of course, assuming that there's funding available. It's coordinated organization. We have best practices. We have standards. We have development plans. It's not as I think within each country there's a governance structure, and within now at the global level. Using the OCG as the formulating body to organize ourselves. It's working out well. It's free and distributable, timely, near real time. It is a essential ocean variable, has a defined mission, and again, we have best practices, and we're at a minimum of in the pilot, and we actually consider ourselves more of a mature network. For coordination, as we mentioned, there are areas and opportunities for coordination, and these are the different sections, mainly for the radio frequency bands. One of the technology uses radio frequencies, and so you have the Americas and Europe and Russia and Africa and Asia countries. And so I'm going to now pass it over to Julien, who is going to delve into the Eurogoose system for high frequency radar. Thank you.
Thank you, Lisa. So yes, I will present quickly the job we are performing in Europe. So led by the HF Radar task team from Eurogoose. In Europe, we are now 24 operators in 12 countries. We have some experiences working together. We have 5 cross-border systems, that is to say, with at least one station in 2 different countries. But for pushing the application of this data and for being also stronger and to contribute at global level, we are starting working as one community. So that is the current map of the systems in Europe. You have in green the operational ones. You can see the differences between long range and higher resolution systems. Some differences between the different areas in Europe, but the network is growing in general. Apart from the numbers of providers, we have to take into account also the marine data existing system in Europe. Copernicus is one, EMONNet that Lisa showed us, and CDataNet. So one objective was to integrate these data in these important marine data infrastructure in Europe. Other projects like JerichoNext, that is a research infrastructure project, worked on homogenization, standardization of the data. That is the key step for being able to implement this data into the marine data infrastructure. We made that thanks to Eurogoose. Eurogoose has an important structure with different working groups with the main actors in operational oceanography in Europe. Eurogoose provides us the framework to work on long term, to being part of a bigger community on oceanography, and also receiving some support for networking, etc. So in Eurogoose, we define this roadmap to work as a group and not as individual institutes. So this roadmap is made with 3 main steps. We first work on networking, performing an inventory to know who we are, running an operational system in Europe. We exchange training, we work together in R&D projects, we exchange best practices. Then the second step is to work in this important step for integration of the data, the standardization. So based on the job performed at US level, for example, with this quartered manual that Lisa mentioned, but we adapted these standards to some European specificities to be able to integrate the data into the monitoring infrastructure I've just commented. And the final goal through this standardization is to capitalize from the good showcases we have in Europe to be able to transfer also good example of application. The final step is to improve the link with global, to act as a HF radar node to improve the integration of the data, and finally also to have a joint strategy for developing the network, not only at national level, but to think about gaps at regional level in the different sea basins of Europe. So that's again a zoom of some systems operating and with the data available now in EMONNet physics. One important step was to improve this access to the data, adding a standardized also quality control. So for that, we worked a lot through this JerichoNext project and defining this European model as a standard now. We had a lot of exchanges with the international community to be compliant with the existing standards in the world. And we want also to contribute into these developments of open tools for the global community, developing tools in Java and MATLAB mainly for the moment. So Copernicus. Copernicus is a very important actor for operational services in Europe. The objective was to integrate the HF radar data into Copernicus. For that, we started with a service evolution project called Increase, and we are now working with the InStack In Situ Thematic Center for providing HF radar products from next year in April, for giving more visibility to this data through these Copernicus Marine Service products. So for that, one necessary step was the standardization of the quality management. So it will give a higher quality to the products than are now available in M&Net physics, giving the same quality management to all these data. So this is the organization. So the different HF radar providers will push the data towards the European node that will manage this centralized data management and will push the data to the global production unit of Copernicus. Then all these data are freely available through the central distribution unit of Copernicus. We put some objectives of implementation. So next year, we have this objective of 37 radio stations through Copernicus. And during the next years, we will work in improving the number of systems available through this system. In parallel of that, so we hope we'll have more systems, as you presented before. So the tendency is a bit constant along the year, but we think that also this cooperation and coordination at European level will help for developing more systems at national level. We have to remind that the nations are founding the operations of the HF radar systems. And finally, to finish with this slide, we'll work also in developing some joint strategy. I put in this slide a map of the main lines of maritime traffic in Europe. That could be one important driver for defining where we have to install systems to have good sulfur occurrence data. So and in parallel, we have the current network. So we'll work on with this kind of drivers and more drivers to try to identify gaps at European level together, instead of looking only with local drivers, nations per nations. And that's all for me. So Albert, I will give you the floor again.
Thank you very much to Hugh, Lisa, and to Julien. So I'll invite Hugh and Lisa to turn their cameras back on so they can participate in the question and answer session. And for the audience, there's one question already and one comment, and I invite you to ask further questions. So let's start with a question from Bert Jones. And it was Lisa who mentioned the pilot on wave measurement from HF radar. Bert's question is, how promising are these wave measurement approaches? I was going to ask you a similar question about how it works and what you can use that wave information for.
Sure. So basically the technology for surface currents looks at the first order Bragg peak to get the signal response from the surface currents, and the wave measurements come from the second order. And I know that from what I am not the expert waves person here, so I'll defer to Hugh and Julien if they have anything else to add. But there needs to be a very large sort of windowing location for the waves. So what you're getting is kind of a bulk parameter from the surface currents, but one of I know that, and I think the phased array might be a little better suited for doing waves, but in areas of high waves or high currents where you can't have wave buoys and the satellite measurements might not be able to get the wave heights, this can be a really useful tool. I know that I think on the East Coast here in the U.S., Rutgers is experimenting and putting out waves information. And so with some good response, I know there's a lot done, and Julien, you can speak to that. Lucy Wyatt is doing a lot with wave measurements as well. So I do think it's promising. I think that, again, you're not going to get really high resolution information, kind of bulk parameters, but it can be a really useful tool. Julien, if you want to comment more, that's great.
I mean, so in Europe, we have some project where we are now trying to use the current capabilities of the tools, of the softwares that are providing these variables, and we'll compare that with some bows, etc. We see HF readers like a complementary platform for measuring waves, not the main one, but as it's on board in the coastal observatory, we should have a look on what are the real limitations and how can we use this other source of information. So we'll have more clear answer about the limitations in the future, I hope, through these projects.
Okay, thanks, Lisa and Julien. We have a question from John Wilkin about the data, but before I go into his question, actually, I'm going to ask Hugh a question about the data. It's a little broader. You mentioned that there's 35 countries participating in the network, and 9, and hopefully soon to be 10, are sharing their surface current data, I presume in real time. Why not more? What are the impediments to data sharing, Hugh?
I guess some of the impediments, some of the nations have, I guess, a strong Navy or military interest in the surface currents, and so they're not willing to share because of that reason. And another reason might that we're kind of finding is a question of the quality control of the data in real time. So we're trying to share best practices for quality control of the data to make the nations and the operators feel more confident in the measurement, and then get the data out on a more wider basis. So those seem to be the two hindrances for sharing the data from some of those countries.
And in cases where there's military sensitivities, is there any appetite to share the data in a delayed mode for more research purposes? I
believe so. We'd have to take it on a case-by-case basis to see who'd be willing to do that.
Okay, so let me ask John Wilkins' question, which is for Julien. The data that's being served via Copernicus, is it archived as total vectors or radial vectors from the individual sites? So the question is, if it is radial vectors, that would allow users to potentially research improved methods for computing the total vectors.
So I didn't put the details of the implementation, but next year in April, the plan is to provide total vectors only and radial vectors from the year after, 2021. No, sorry, 2020. Radial vectors. So that's why we started the data flow, as you saw in EMONET physics, with total radials. So we have in place this data flow, and that's why this first step will be only with totals. But mainly from the modeling community, we received the requirements on delivering also radial data. So we'll have that for sure from April 2020.
Okay, thanks, Julien. We have a comment on the wave measurements, actually, from Lucy Wyatt, so I'll read it. With a phased array radar and good radar data quality, we can measure the full ocean wave directional spectrum and derive wave height, peak direction, and period and other parameters therefrom. These can be mapped over a smaller area than currents, but sufficient to see changes in the wave field in space and time. So that's a little bit of update on what is the potential of wave measurements from HF radar. Thanks, Lucy. Let me ask a question to Hugh. So you showed the growth in the network. Well, you all showed growth in the network in different areas. I presume, so it's really still growing quite fast. I presume that means there's both research and operational users of the HF radar current data. Is that correct?
Yes. Yeah. So like within, from my perspective, in the Mid-Atlantic of the U.S., an early user of the data was the U.S. Coast Guard for search and rescue. So it was a combination of the measurements from the HF radar, but then also then providing those measurements to a regional ocean model that John Wilkin operates, and then also a statistical model that was developed by Jim O'Donnell and his group at the University of Connecticut to provide a short-term prediction of what the surface currents are like, because it's a prediction that the Coast Guard values the most, because then that provides some guidance to them as to where they want to conduct their search. But the measurements of the ocean currents were critical to being able to provide that prediction. And then I was hoping to show the video that talked about there was an oil spill off of Santa Barbara back in 2012, and the HF radar measurements were used in the response to the oil spill. But I think we can include a link to that video through the webinar archive.
Yes, we can definitely do that. All right, so the follow-up question on that is that I noticed that in one of your slides that I think it was a slide about the Korean HF radars, that some of those agencies operating them were research agencies and some of them were operational agencies. And I presume that's the case for the operators of the HF radar around the world. How do with operational uses of the data that comes out of it, how do you negotiate that operational delivery of the data when the operator is a research institution?
Yeah, so within the US, I can speak to that. So I'm a member of MARCOOS, the Mid-Atlantic Ocean Observing System. So it's one of the 11 regional associations of the US Integrated Ocean Observing System. And so we just went through the process of becoming a certified agency for IUS. And so through that certification, we documented all of our best practices, the quality control that we provide to the data, and an explanation of our procedures to make it an operational product. And so, for instance, working with the Coast Guard, we developed operational metrics that we have to meet every progress period to ensure that the data is available and is of a high quality. So me being at a research institute, we're still able to deliver an operational product that's used by our stakeholders in our region.
Okay. Let me turn to a question for Julien. You mentioned that in Europe, there are 5 cross-border systems, so operated by more than one country. And I'm kind of curious about that, about what level of integration is needed. Obviously, I'm guessing that the funding streams are national. So how are the choices about even what equipment you buy, what standards you're operating on? How does that negotiation take place between the different countries that are running the common system?
In that case, many of these examples are using some cross-border funding called Interreg in Europe, who helps the development of the observing system between 2 cross-border regions. Also, in some critical points, you need the other region to install a radio station to be able to have a good total coverage of your area. So that's the case in the Bay of Biscay, but also there are good examples between Portugal and Spain, between Italy and France, between Malta and Italy. So the geographical characteristics of the European seas obliged us to work together in a lot of cases.
Okay. Well, I'm interested to hear that a cross-border funding stream was part of the solution in many cases. That's an interesting hint and clue about how to make that work between nations. Let me turn to Lisa. So you talked about the different applications, but anybody can answer these questions: maritime operations, oil spill response, water quality, ecosystem management modeling, water quality twice. So I wonder if you could just go into a little more detail about what are the operational pathways for those uses. We heard about one for search and rescue from Hugh in the case of Maracus, but maybe you could tell us about one or more of the other ones, particularly water quality. How is the HF radar data used for water quality management purposes?
Sure, I can speak to that. So in one of the regions we have here locally in San Diego, the border of U.S.-Mexico, there are some water quality issues with untreated flows near the border. And so when there are, actually that was some of the original funding for the HF radar systems in the area to begin with, to look at the current circulation during storm events. And so right now what happens is there's a simulation, and so simulated particles are infected through the currents and are tracked over a 3-day period, and a trajectory shows a trajectory of where the currents are going. And so the Department of Environmental Health and through some research realized that when the currents are flowing north, there could be some high levels of contamination. And so the Department of Environmental Health uses that information to go out and collectively, adaptively sample for any kind of water quality measurements. Also, we use the data to look at point source discharge, say even like river flow discharge. So after a rain event, there can be contaminants that are flowing through the systems. And so infecting those particles or simulations through surface currents and looking at the extent of the range of where those water masses could flow and affect coastlines has been some of the work that is done. Additionally, some of the operational uses, when the Office of Spill Prevention and Response was looking at using the surface currents to integrate into their emergency response planning, we developed a specific data format to work with their GIS system to ensure, that they had their data stream. Now that and so that was early on as the networks were being developed, kind of in the 2005, 2006 timeframe. A lot of applications are starting to use some of the more common data standards, and so now folks can pick up that data feed, through wherever as products and operating pictures and tools for each of the agencies are being developed. It's pretty easy to integrate. And some of the systems also integrate and or use the data as a checkpoint. So, what is their model showing? What is their prediction showing? What are the surface currents showing? So both integration and validation.
So let me tease out the water quality example with the outflows and the northward flow from Mexico. So you mentioned the Department of Environment, which I presume is a state department. Is that right?
That's correct.
Yeah, and in the response to that, if there is a bad water quality event, it's related. I guess it can be related to beach closures. It could be related to management of aquaculture sites. How those things are actually managed at an even more local level than the state level, no? But the county level?
County level, yes, exactly. County, okay. And yes, correct.
And so have you at Scripps been able to see that whole chain of event? Has there been some beach closures because of the information gained from HF radar and modeling and the evaluation by the department at the state level, and then an action taken at the county level?
Yes, absolutely. So early on, it's introducing the data and the use of it, and now kind of there's a very much a hands-off use, interaction because all of these systems are in place. But That's exactly what happens. Is when currents are kind of flowing to the north via showing off of the HF radar, the county will go out and adaptively sample and or preemptively close the beaches, which they haven't been able to do in the past. So after years of assessment and validation and showing that there is a very high correlation, I think they feel more comfortable with being able to close the beaches earlier in events. And so it's been a really interesting process to see how that information goes into management decisions and become really useful and valuable.
Okay, thanks. That's a great success story, and it's really interesting to hear. Do you get any feedback from on what would be could be improved in the HF radar products?
We do. Right now we kind of annually or check in, and there's like, yes, we're still using the data. It's fabulous. Thank you. And but there are in different regions, there are definitely areas where improvement can be had. I think a lot of it is actually either tackling the actual issue with infrastructure and whatnot in the border areas, but also in increased monitoring. But usually it's more kind of in other applications. One of the things that HFR does really well, getting that surface current measurement, but it is kind of the first measurement is about 1.5 kilometers offshore, and so any sort of shoreline hugging feature might not be captured in HF radar. So coupling the HFR with sort of nearshore models, I think, is really the step for really looking at coastline issues.
Okay, thanks. That's really interesting. We have a question from Art Allen, which I think is for Julien, which is what external outreach has been made in Europe for using HF radar for oil spill or search and rescue trajectory models?
So as you mentioned, in some cases, HF radars are installed by a research institute, so for research purposes. And from our experience, that's a pity that these data that are available are not used, for example, by the search and rescue agencies or the agencies responsible for the response against pollution. So that's why we are asking this institution to deliver the data without a real commitment in the delivery, because that's a problem for them, of course. They are not an operational agency. But we prefer to have access to this data without this real commitment. So we are gathering all the data from operational agencies and also from some research institutes. So then we try to push some collaboration or coordination at European level using infrastructure like EMSA that are coordinating things between the different search and rescue or maritime agencies around Europe. So our first step was to work on standardizing the basic data products, but our next goal will be to standardize also the applications. So we'll work jointly with this kind of structure to try to push the applications in the different countries in this kinds of toward this kind of users.
Okay, and so actually, the question it's related to something that Lisa brought up, which is a growth area for HF radar, which is the operational integration into products. But maybe Hugh or Julien can also pitch in. We heard that in the case of Maracus, there is an operational ocean model that is assimilating this data for use. So is that you talked about this, Julien, as a future goal of the European work is to standardize how that is done or standardize how that is delivered. I'm just wondering if there's any best practices or advice around the assimilation into regional models that's available and published. Maybe that's a question for Hugh or John Wilkin if he's still listening.
Yeah. So yeah, I guess you want to be friendly with a modeler to make sure that the measurements that you're making are valued to that person to either assimilate or validate their model. And so a close working collaboration with an ocean modeler is a good relationship to have for an ocean observer.
And is that something that you see across the HF radar network?
Yeah, so I think on the West Coast, I think there's a model for the entire U.S. West Coast, and that model is using the HF radar data. Same thing here for the Mid-Atlantic. Julien, I guess, can you comment on ocean model use within Europe?
So we have some examples. From now, Copernicus is not assimilating HF radars in their model at regional levels. So we have other examples more at local level. But we need more experiences to define real best practices. We try to provide some key information from the HF radar community to help modelers to understand what is the real information inside the data. And we think we could work on specific products for data assimilation with some kind of filters that will isolate the signal that are interesting to assimilate in their models. Otherwise, it's a bit difficult with the total signal present in the surface currents to assimilate. And especially the high frequencies is difficult to assimilate. So some modelers are dealing perfectly with that, and they're able to do that. But maybe the collaboration between both communities will help in developing and in transferring best practices in a wider scale.
Lisa, you look like you.
Oh, sure. Yeah, I was just going to comment too. In the U.S., there are some other efforts as well, East Coast and West Coast, and then kind of at a national level, NOAA, the National Center for Environmental Prediction, NCEP, is they're starting to integrate or look at the radials as well, and sending those through and getting the radials archived within the NOAA Centers for Environmental Data, NCEI. The acronym wrong, but that's kind of done. That pathway is open for government, but then making sure we have the pathway open for all of research is where kind of the Rutgers effort is happening. So kind of a government and research level to ensure there's access.
Okay, and John Wilkin has actually pitched in, and he says that there are several research results with data assimilation, but it's still somewhat experimental. There's different approaches. Maracus uses total current, and PAC-IOS is using radial current. And one of the challenges is the quality control for automatic use and the objective specification of the observation error. So it sounds like it's still a very active area of research for the integration of the information into models. Lisa, you talked about the challenge of the very nearshore currents. Are there complementary, you talked about using models to try to understand what the nearshore currents would be, because the HF radar starts 1.5 kilometers, if I understood right, offshore. Are there other observing technologies that could help measure those nearshore currents?
I'm most familiar with using wave measurements and high resolution bathymetry to get the alongshore currents. So I know that that having the bathymetry really drives a lot of the nearshore processes or the alongshore processes. And getting high resolution bathymetry can be, a very time consuming and expensive process, but it definitely can be done, especially for areas of big concern. To my knowledge, the best observations are wave observation with high resolution bathymetry feeding into a model.
Okay. And what about at the far field? So the HF radars can measure out to about 200 kilometers. Is the broader current field measured by altimetry or by drifters? Is that also sort of combined with HF radar to create products that cover a broader spatial extent?
I'm not aware of any product that's simulating like altimetry with HF radar. But it's come up as a research topic to like what is it? What is the product? Oscar that NASA provides, and there's gaps near the coast, and HF radar could just fill in those small. But when you're talking about a global product like Oscar, it's a small addition, but there could be of some value to that.
In the framework of Copernicus, we have one little service evolution project working with altimetry and HF radar and trying to identify the use of one of the data for improving the products of the other one. And the next step is to work also with data blending to be able to provide one single products for coastal currents. But in the future also, the satellite community will try to have new sensors to improve these products at global level. So for sure, the HF radar community will help this community to improve these remote sensing products also in the future.
Let me turn to best practices for a minute. All of you have mentioned best practices. I presume they cover the best practices around actually taking the observations as well as the quality control of the observations. Are these published and available, and how much do they differ around the world? I'll open that to all of you. Maybe let's start with Hugh, then go to Lisa and Julien. Hugh?
Yeah, so the group in Southern California authored a best practices manual that's now become a community standard, and I think that's been shared. And my recent conversations with Mark Bushnell on the Ocean Best Practices community, so we're trying to get that document submitted to that organization as a best practices document for the installation and operation of an HF radar station. I'm not aware of any best practices documents for data management or the flow of data, but there could be one out there.
So Julien mentioned that one of the challenges for Europe was the standardization of the quality management. So maybe you could address that, Julien?
Yes. So we have a recent deliverable available from the Jericho Next project. So in one of my slides, you have the link to be able to download this deliverable. So it's only on the European data model. So we are converting in a best practice at European level. And then about the general best practices in terms of installation and management, we are planning to work at the beginning of next year to try to complement the US documents, taking into account some characteristics on the phased array systems. We are working on that with Jochen Horstmann, with Céline Quentin, and so we'll see the results. So we have a few months to work on that, but it's also one objective in the Jericho Research Infrastructure project. And of course, the results will be available for everybody. Yeah.
Go ahead, Lisa.
Sure. And actually, I don't know if you can make me the presenter we don't have to, but there is a they're actually through the Integrated Ocean Observing System and through the National High Frequency Network within the U.S. There is a QuarTOD, which is quality control real-time data. There is a manual for near real-time quality control of high-frequency radar. So thanks.
Okay. And let me, so you're putting that up on screen.
Can folks see that? Are you able to see that?
Yeah, we can see it. No, we can't quite see the link, so we can put the link into the description of the video when we post it. So people can link directly to this.
Here are the documents for some of the quality control documents and guidelines.
Okay, and we are actually out of time, but I do want to ask another question because I was quite curious about this. And Lisa, you mentioned that some of the future growth areas for HF radar, including calibration via drones, which sounds quite interesting, but I'm going to ask a question about another concept, which is about meteo tsunami warnings. So these are wave events that are created by storm systems and can have the same devastating effects that tsunamis have locally. Given the scope out to 200 kilometers of HF radar, what's the time scale possible for a warning for immediate tsunamis?
Yeah, I can take that one.
Sure.
So the one thing to be cognizant of is that you need a shelf for that tsunami wave to shoal upon for the radar to detect it. If you don't have a shelf, then the radar it'd be very challenging for the radar to detect that signal. But we've seen early detections on the order of about 30 minutes before that wave makes its way impacting on the coast. So that's kind of the order of warning that you can receive with the radar.
Okay, thanks. It's quite a promising future area. We are out of time, so in general, I do want to thank you, Hugh, Lisa, and Julien for having presented the HF Radar Network. From the Goose perspective, this really does bring us closer to shore along with the tide gauge network, and it's really good to see that evolution of Goose. I'm happy to see that. So thank you again for your presentation, and we will be posting this on the Goose website and on the YouTube channel. Thank you to everyone.
Thanks, Albert.
Thank you.
Appreciate it.
Thank you very much.